Hello programmers, back to another video, and in this video I will discuss about CPM and PERT, and basically I will discuss about what are those topics and exercises of those topics. Okay, so I think if you are watching this video, you are an exam candidate, and as like me, I am also an exam candidate. So why are you waiting for? Let's jump into the session. Okay, so at first, let's check the topic what I will discuss about the whole session. So before jump into the lecture, I want to take one thing to you, because this lecture will take a long time, because I have total how many slides? 45 slides to complete. So at least 1 hour required to complete this full topic. Okay, so take your time and get back in this video again. So let's start. So the topic I will discuss in this lecture is critical path method, CPM, and program evaluation and review technique, which is also called PERT, uh, the short form of it. Okay, so let's discuss about those topics: CPM, critical path, and PERT, etc. Okay, so what are they basically? So the critical path method is a project management tool used to determine the longest stretch of dependent activities and measure the time required to complete a project. So next I will discuss about the critical path. So what is basically critical path? So basically I will critical path consists of all activities with zero float. This path dictates the project's minimum completion time, and any delay in these activities will delay the entire project, and will solve mathematical problem of critical path analysis. Okay, in the later slides. After that, let's discuss about the PERT, so which is also called project evaluation and review technique. So it identifies all tasks needed to complete the project along with their milestones, where tasks are represented in a flowchart format showing dependencies between them. So let's discuss one more thing. Basically, we will need this thing at the end, second part of this uh, video. In the first part I will discuss about CPM, and in the second part I will discuss about part. So in the part uh, we need this topic. Okay, so it's basically three time estimates for each task, which is one. The first one is optimistic time, which is basically the shortest time to complete a task. In the second one is pessimistic time, which means the longest time to complete a task. Finally, the most likely time, the best guess of how long a task will take. I hope you will understand all of them. Okay, so let's jump into the 6 steps of CPM and PERT, and why we need this basically. So to solve a critical path analysis problem, we have to follow those 6 steps every time. Okay, so mm and this is also an important topic which can be come into the exam. So this is very much important. So the first step is define the project and prepare the work breakdown structure. Second step is develop relationships among the activities. Decide which activities must precede and which must follow others. Third step is draw the network by reconnecting all of these activities. Fourth step is assign time and or cost estimates to each activity. Fifth step is compute the longest time path through the network. This path is also known as critical path. The final step is use the network to plan, schedule, monitor, and control the project. Okay, and you have to memorize all those steps, and this is very much important. In the next slide, let's jump into the actual problem. Okay, so this is the first problem I will discuss, and this is a long this will take a long time to uh, debug this thing. So there are some activities A to H, and each activity has a description. For example, A means build internal components, B means modify roof and floor, C means construct collection stack, D means pour concrete and install frame, E means build high temperature burner, F means install pollution control system, G means install air pollution device, and finally H means inspect and test. And you can see here intermediate predecessors, and it's basically the relationships, okay, the parent child relationships, you can say. For example, mm there are no parent of A and also B, but for C, we have to complete the activity A to complete activity C. To complete activity D, we have to complete activity A and B. To complete the activity E, we have to complete the activity C. So to complete the activity F, we have to complete the activity C again. And to complete the activity G, we have to complete the activity D and E. And finally, to complete the activity H, and we have to complete the activity F and G. In the next slide, you can see there are some numbers, basically the activity time. So at first, let's check the question basically here. So the question will be identify the critical path, and another thing is calculate the slack time. We will discuss what is slack time after that slide. Okay, so this is the second part of the question. Basically all the things are same, and just we I included a time here, okay, and this is in weeks. So for example, to complete activity A, it will take 2 weeks. To complete activity B, it will take 3 weeks. To complete activity C, it will take 2 weeks, and rest of them you can already understand what this values means, okay. So total weeks, what, 25 weeks. So we have 25 weeks to complete the whole project, okay. So let's jump into the next session. So here are this is the diagram basically, and I will use this diagram to solve the entire problem. And before jump into the problem, let's discuss about what this values means. So A means the activity name or symbol, which is basically this one, activity A B C D E F G H. And 2 means the activity duration, which basically the time, weeks. And for example, for activity A, it requires 2 weeks, okay. So it requires 2 weeks. So here you can see the es means earliest start, ls means latest start, ef means earliest finish, and lf means latest finish. So let's discuss about those topic. What is earliest start, what is latest start, what is earliest finish, and finally what is latest finish. So earliest start is basically the earliest time at which can an activity can start, assuming all predecessors have been completed. Earliest finish is basically the earliest time at which an activity can be finished. Latest start is basically the latest time at which an activity can start, so as not to delay the completion time of the entire project. And finally, the latest finish is basically the latest time by which an activity has to be finished, so as to not delay the completion time of the entire project. I hope you understand all of those topics. If not, just pause the video and read those terms carefully. Okay. I jump into the next session. So next slide. So before solving the problem, we have to know what is forward pass and what is backward pass. But I think you can't understand what is forward pass and backward pass for now. And I will discuss those things in the mathematical part. Basically, while I will discuss about the exercise, I will discuss about the forward pass and backward pass. So before jump into the problem, let's just understand the rules, or just know the rules to solve the forward pass and backward pass problems, also the slack time. So forward in the for forward pass, we have to calculate the earliest start, which is basically the maximum of earliest finish of all intermediate predecessors, okay. And the earliest finish will be the earliest start plus activity time. So the in the backward pass you can see the latest finish will be the minimum of latest start of all intermediate following activities, and what for latest start will be the latest finish minus activity time. Basically here I just want to say in the forwarding pass we have to count the maximum value, in the backward pass we have to count the minimum value. Okay, and in the forward pass we have to just add those values, and in a backward pass we have to subtract those values. So let's jump into the slack time. So what is basically slack time? Okay, so slack time, slack is the length of the of time an activity can be delayed without delaying the entire project. And you can calculate the slack time using two rules or two equation, and one is ls minus es and another one is lf minus ef, and you can use any of the equation. Both equation will generate the same answer. Okay, so let's check the question again. So this is the question. So there's are the activity and there's are the time required to complete this activities. Okay, so you see in the previous slide that, for example, this slide, that a and b, for activity a and b there are no intermediate predecessors. That means you can start a and b directly. Okay, you can start a and b directly, not required any predecessors. Okay, basically. So let jump in the current slide. Okay, so to solve this problem, at first we have to take an starting node. So this is the starting node and I just called it s. S means the start node, and here the value of start node is 0. Value means that time, value means this time, or so called weeks. And in a left part it means what you already see in this slide. What is this actually? So it is basically the earliest start, this is the earliest finish, this is the latest start, and this is the latest finish. Okay, so after that uh, after that just jump create a direction from S to A, and this is the A node and this is the F sorry B node. Sorry, I can say node, I will say activity, basically A activity and B activity, and this is the starting node. Okay, and okay, this is the activity and this is the b activity, and time requires is for activity a activity is 2 weeks and b activity is 3 weeks. Okay, so a activity is 2 weeks and b activity is 3 weeks. After that uh, uh, c will be draw here. Basically for c we have to we have to mm, for c we have to just complete the activity a. Okay, so after completing the activity A, we can complete the activity C. We already saw this thing in a previous slide. And after C, okay, I forgot one thing. So how can I calculating those values actually? Basically those values. So for example, for A, and this is the activity time, and for B this is the activity time. So this is the earliest start and this is the earliest finish. So earliest start basically this value. So I just copy this value and paste it here. Also I copy this value and paste it here for B. And what I have to do next, just add those values. 0 plus 2 is equal to 2, so this is the earliest finish time, and 0 plus 3 is equal to 3, which is also the earliest finish time. After that for C, similarly we have to calculate it, and for C this is the earliest start. So I just copy and paste it here. This is the earliest start, and what will be the earliest finish time, and this is basically the earliest start plus activity time. Okay, earliest start plus activity time, just add those values and you will get 4. After that you can see D is here, and you already see that for D we have to complete the activity A and B. Okay, for D we have to complete that activity A and B. So how can I calculate D? How can I calculate D? So that activity time for D is 4, and the earliest time is 3. So there are two earliest time basically. One is this and one is this. So what will I have to pick? Basically I have to pick 3. Why? So in the previous one slide, I discussed about forward pass and backward pass. Basically, in the starting to solve this problem, start part of to solve this problem, we have to complete the forward pass. So we already in the forward pass session. Basically I just forward those activities, s to a, s to b, and a to c, a to d, just forward passing it. Okay, it means the forward pass. So in the forward pass time, we have to count the maximum one. We have to count the maximum one, basically the maximum earliest finish time, maximum of earliest finish time. So there are two earliest finish time, one is 2 and one is 3. Which is the maximum one? So 3 is the maximum one, so I have to count 3 as the earliest finish time of D. Okay, so this is the 3 is the earliest finish time of D. So what to do next? Just add those values. 3 plus 4 is equal to 7. So 7 is the earliest finish time for D. After that, E. So to complete the task E, we have to complete the task C. Okay, we already saw it in the question. So here basically this is the earliest finish time which will be used for earliest starting time for E activity. So what is the earliest finish time? That so earliest finish time will be 4 plus 4 will be 8. In the next slide, just I will discuss about F activity. To complete the F activity, we have to complete the activity C. So we already complete the activity C and jump into the activity F. So for F, the activity time is 3, and the activity starting will be 4. Earliest start will be 4, and what will be the earliest finish? So earliest finish will be 4 plus 3 is equal to 7. Okay, so F is done also. So what next? Next will be G. Okay, so for G, we have to complete activity E and activity D. So we already complete the activity E and activity D. Now it's time to complete the activity G. So the activity time for activity G is 5, and what will be the earliest starting time? So there are two activity basically. One is E and one is D. So we have to count the maximum one because we are in the forward pass session. We are in the forward pass session. So in the forward pass session, we have to count the maximum one, and for E and D, which is the maximum, 7 or 8? 8 is the maximum. So we have to take the value 8 here for earliest start of G activity. So it's done. So what next? So this is the final step, which is H, and for H, the activity time of H is 2, and what will be the activity earliest starting time? So earliest starting time will be the maximum of earliest finishing time of F and earliest finishing time of G. So I miss anything? Not. So for 7 and 13, what value is the maximum one? So 13 is the maximum one, so that's why I just take it and paste it here. So for H, the 13 will be the earliest starting time, and what will be the earliest finish time? 13 plus 2 is equal to 15. So 15 will be the earliest finish time, and we just end up here, and no other activity will be given in the question. So whenever we reach the end part, basically the in the H activity, what I have to do? Just copy the earliest finish time. Sorry, earliest finish time and paste it here. Basically, latest finish time. Copy the earliest finish time and paste it here in the latest finish time. Okay. So I just paste it here in the latest finish time. So how can I calculate this value, which is latest start? basically I have to subtract those values. 15 minus 2, 15 minus 2 what? 13. 13 will be the latest starting time. Okay, so 13 will be the latest starting time for each activity, and we have to we are already in the backward pass. We already complete the forward pass, and now we have to complete the backward pass to fill up those values, those values actually. Okay, latest finish start and latest finish, and we didn't complete any of those. Okay, just starting from here, and this is the backward pass session. So we already calculated the backward pass for each activity. So let's check each activity, the parent node of each activity. It's basically the F activity and G activity, and we can start any of this. Okay, so let's start with this. So what will be the uh, latest finish time for G activity? So it's basically 13, because the latest starting time will be of H is 13, so this will be count for latest finish time of activity G. Just copy and paste it here. Okay, so what will be the latest starting time? Is basically the subtract, if you subtract those values, 13 minus 5 is equal to 8, and this is the latest starting time of activity G. So now I can calculate activity E and activity D. Okay, and for example, I just here I calculate both of them. So okay, at first, okay, let's jump into the next slide. So for activity E and activity D, let's check. So what is the latest finish time? So latest finish time will be activity starting time of activity G. So this is the value of activity latest finish time activity G is 8. So we just copy and paste it here and here. Okay, latest finish time, and this is the latest starting time of activity G. After that, I have to calculate the latest starting time for E and also for D activity. So how can I calculate this? Just subtract it. 8 minus 4 is equal to 4. 8 minus 4 is equal to 4. Okay, we just completed 4 activity D, E, G and H. Can I complete activity B? Yeah, I can complete activity B. So how can I complete? Just copy the value 4 here. So this will be the latest finish time for activity B, and for latest starting time for activity D. And what will be the latest starting time of activity B? This is basically 4 minus 3 is equal to 1. So 4 minus 3 is equal to 1. Okay, so now on the other hand, we have to we here I calculated the latest starting time and latest finish time for activity F. So what is this? Basically simply just copy the latest starting time of activity H and paste it here, which is the latest finish time of activity F. So to calculate the latest starting time of activity F, you have to just subtract 30 minus 3 is equal to 10. So this is the latest starting time of activity F. After that, you can see there are two nodes, okay, or say or so called two activities E and F, and both of those activities comes from activity C, and this is the time you have to check, uh, because in a forward pass session we just take the maximum value. Okay, we just take the maximum value from two activity, and in a backward pass we have to take the minimum value of two activity. Since activity F and activity E, both of the activity came from activity C, in this case I have to take the minimum activity. Okay, minimum latest starting time. Okay, what will be the minimum latest starting time? 10 or 8? 8 is the minimum latest, sorry, latest finish time basically. Uh, sorry, yeah, latest finish, sorry, latest starting time 4 and 10. So what is the minimum of latest starting time? Basically E. The value 4 is the minimum of those values. Okay, so latest finish time for activity C will be 4, because 10 and 4, the minimum one is 4. So 4 is the latest finish time for activity C. So what is the activity latest starting activity of activity C? Latest starting time of activity C is basically the subtract of 4 minus 2 is equal to 2. So 2 is the latest starting time of activity C. We just completed B, C, E, D, G, H and F activity. Just 2 activity left. So for activity to calculate the activity A, we have to check uh, uh, two paths, basically this one and this one, and both C activity and D activity came from activity A, and in this case again from as like this, again I have to calculate the minimum latest starting time from C and activity D. Okay, so from 2 and 4, what is the minimum value? So minimum value is 2. So 2 is the latest, 2 will be the latest finish time for activity A. So 2 is the latest finish time of activity A, and what is the latest starting time of activity A? 2 minus 2 is equal to 0. So 0 will be the latest starting time of activity A. So finally we end up here in the activity S, which is the starting node. So we just copy the latest uh, starting time of activity A and paste it here, and also copy the latest basically what, did I mistake anything? No, I think yeah, one thing. Oh, sorry for that. For starting node, all those values are will be 0. Okay, for starting node, all those values will be 0, and we have to calculate basically those activity A, B, C, D, E, F, G, and H. And for the starting node, all the values will be 0. Okay, so this is the answer. So this is the final uh, critical activity path. Okay, basically this one is uh, critical path analysis. So now what is the next step? We have to calculate the, like, minute, 1 minute please. What is the question? Basically I just forget. Okay, let's check the question here. So what the question says, identify the critical path and calculate the slack time. So we already uh, complete a 90% of this solution. So now I have to calculate the now I have to identify the critical path. Okay, so after that I have to calculate the slack time. You can see the relationship here. Basically we just follow in the whole time. Okay, so now let's jump into the last part of this solution problem. Okay, I think I end up here. Okay, so this is the actual critical path. Okay, okay, this is the actual critical path. Now how I understand this, basically you have to calculate the slack time to understand this. And to calculate the slack time, how you can calculate it, it's simple. Basically you have to subtract those values, basically the earliest start and latest start. So if you subtract from latest start minus earliest start, you can find 0 here. So if you get 0, and this will be this activity will be count. Okay, and if you get another value, then you have to skip this activity. For example, from the starting node, we just have a look from of activity A and activity B. What is the difference of those values, or those values? You can take any of them. I already say, to calculate the slack time, you can either use those values and either use those values. Okay, and to for example, if I calculate this, 1 minus 0 is equal to 1, 0 minus 0 is equal to 0. For in here I get 0, so that's why I have to take this path. Okay, so after that there are two activity, C and D. So for C, I have to calculate 2 minus 2. Here I again get 0. So this is the path I have to take. After that, there are two parts from C, E and F. And for E, we just get 4 minus 4 is equal to 0. So I have to take this path again, not this path basically, because 10 minus 4 is equal to 6. This is not equal to 0. After that, from E, uh, I have to go G, and for G, the value is slack time is 8 minus 8 is equal to 0. So I have to take this activity. So from E, I have marked uh, this path G. Okay. After that, uh, I have to go to H, and here I again see 30 minus 13 is equal to 0. So I again take this path. Okay, because here I get the value 0. Okay, so this is the activity of this problem, activity critical path of this problem. So what is the answer? Answer is A to C, C to E, E to G, and G to H. Okay, so A to C, C to E, E to G, and G to H. So this is the critical path of this answer, first answer. So let's jump into the second answer. So second answer basically the slack time. So we already calculate it. What is the slack time? So I just put the values here. Okay, put the values here, and how can you calculate those values? For example, let's take this example. Take this activity F. So get back to the final answer. So for F, just have a look. 10 minus 4, what is the value? 6. So 6 is the slack time for F. 6 is the slack time for F. For example D, if I have a look at D, 4 minus 3 is equal to 1. So 1 is the slack time for activity D. So just put it here, activity put it 1, and this is the slack time for activity D. Similarly, you have to calculate others values, and maximum of those values are 0. Basically, A to C, E to G, and G to H, all those values are 0, and you have to calculate the rest of those values. Okay, and what is will be the critical path is basically you have to print yes or no basic. Okay, so here I just printed yes or no. So for 0 you have to print yes, sorry, you have to write yes, and for other values you have to write no. For example, I write no for 1, 1, and 6, and for the rest of the value activities I just write yes. Okay, you already understand this from this critical path. Okay, so this is the solution for the first problem. So let's jump into the second part of this video. So this is part, and this is the question basically. In the part analysis, there are three values. One is optimistic time, one is most likely time, one is pessimistic time. So these are the activities: 1 to 2, 2 to 1 to 6, 2 to 6, 2 to 3, 2 to 4, and 3 to 5, 4 to 5, 6 to 7, 5 to 8, and 7 to 8. Basically, there are total 8 activities, 1 to 8. Okay, and these are the values of optimistic time, most likely time, and pessimistic time. And I already discussed what this means in the third or fourth no slide, uh, as can I remember. Okay, so what is the question here for this for part analysis problem? So the first question will be calculate time estimate for each activity. So I have to calculate the time estimate for each activity. After that, it says identify the critical path. Okay, to calculate the time estimate for each activity, we have to use a equation. We'll discuss it later. So I will discuss it later. In the third question, it says calculate standard deviation and variance for the critical activities. Calculate standard deviation and variance for the critical activities. Basically, after completing the second part, I have to calculate those values, standard deviation and variance from this answer. Okay, after that, the final question is says find the probability that the project will be completed in 35 weeks. Is it possible, or there can be a delay? Okay, I have just find it here. So let's jump into the second part, first question basically. Before jump into the solution part, just one, I remember one thing: what is optimistic time, most likely time, pessimistic time. So optimistic time is basically the shortest time to complete a task. Most likely time is basically the best guess of how long a task will take. Pessimistic time will is the longest time to complete a task, and these are the equations for calculating the variance and standard deviation. So the equation is for equation of variance is tp minus t0, sorry, to divided by 6 whole square. Okay, and for the equation is of standard deviation, sigma equal to root over or square root b is equal to Tp minus To divided by 6. What is Tp and To? It's basically those values. Let me show you here. So this one is Tp, this one is Tm, and this one is To. Tp, time pessimistic time. Most likely time means Tm, and optimistic time means To. I hope you understand those values. Okay, so here this is the equation of time estimate of TE. Basically the first question, calculate that estimate, calculate time estimate for each activity. For this question, for the first one, I have to follow these rules. Basically time estimate TE is equal to TO plus 4TM plus TP is divided by 6. Okay, this is the equation. I have to follow this equation to solve the first problem. Okay, let's jump into the solution. So this is the first question answer. So I just copy and paste all of those values, activity values, and optimistic time, most likely time, and pessimistic time. After that, this is the time estimate, and how can I calculate, how I calculate those values? Just follow this equation: To plus 4Tm plus Tp divided by 6. Basically I have to just uh, count this value: 3 plus 4 into 6 plus 9, and after calculating the addition, divide the answer with 6. Okay, and you will get 6 as the estimate time or time estimate. For the second activity 1 to 6, just use 2 plus 4 into 5 plus 8. After calculating the addition, just subtract it, sorry, divide it by 6, and you will get 5 here. And you have to follow all other values in the same way. Okay, so after that, uh, let's jump into the second question, which is basically identify the critical path. So since we are in the path analysis problem, in this case, how can I identify the critical path? Because here it gives me activity like in this format and some values. Okay, so for example, I just omit those values: optimistic time, most likely time, and pessimistic time. I don't need these values to solve this part. Okay, I just need activity and time estimate. So this is the critical path. So 1 to 2, so just I write 1 to 2, and what is the time estimate for this is equal to 6. 1 to 6, 1 to 6, what is the value? 5. 5 is the time estimate for 1 to 6 activity. 2 to 3, 2 to 3, what is the time estimate? 12. So write 12 here. 2 to 4, what is the time estimate here? Is equal to 5. So 2 to 4 is equal to 5. 3 to 5 is equal to 11. 3 to 5 is equal to 11. 4 to 5 is equal to 7. 4 to 5 is equal to 7. 6 to 7 is equal to 9. 6 to 7 is equal to 9. 5 to 8 is equal to 4. 5 to 8 is equal to 4. 7 to 8 is equal to 15. 7 to 8 is equal to 15. Okay, after completing the critical path diagram, you have to check how many ways you can reach 1 to 8. Okay, so this is one way: 1 to 2, 2 to 3, 3 to 5, and 5 to 8. This is one way. The second way is 1 to 2, 2 to 4, 4 to 5, and 5 to 8. Okay, and you have to check this is a directed graph also. I think yeah, you skip this part here because maximum most of the time it is in the right direction, but it is important to check it before just writing those uh, directions. Okay, so number one is 1 to 2, 2 to 3, 3 to 5, 5 to 8. Second one is second route is 1 to 2, 2 to 4, 4 to 5 and 5 to 8. Third route is 1 to 6, 6 to 7, 7 to 8. So let's jump into the second part, critical paths. So there are total 3 parts to go from uh, the activity 1 to activity 8. Okay, there are total 3 parts. So the first path is 1 to 2, 2 to 3, 3 to 5, 5 to 8, and you have to just add all those values. Basically the activity time 6 plus 12 is for 1 to 2, 6 1 to 2 for 1 to 2 is basically 6, 2 to 3 is basically 12, 3 to 5 is basically 11, 5 to 8 is basically 4. Okay, and add those values and you will get 33 as a result. After that, for path 2, which is the path 1 to 2 to 4 to 5, 5 to 8. Okay, uh, 1 to 2 the activity time is 6, 2 to 4 the activity time is 5, 4 to 5 the activity time is 7, 5 to 8 the activity time is 4. So the sum of all those values is 22 w. W means here week. Okay, 22 weeks. For the third path, similarly you have to calculate those values 1 to 6, 6 to 7, 7 to 8. So for 1 to 6 the activity time is 5 weeks. For 6 to 7 the activity time is 9 weeks, and for 7 to 8 the activity time is 15 weeks. So the total uh, sum of those weeks is equal to 29 weeks. Okay, after that, how can you calculate the critical path? You have to count the maximum one all of those values. So I have to count the maximum of path 1, path 2 and path 3. So 33, 30, 22 and 29, the maximum is 33. So this is the critical path. So critical path answer is 33 weeks. Okay, after that I have to calculate standard deviation and variance, sorry, standard deviation and variance. Okay, so this is the equation for standard deviation and uh, this is the equation for standard deviation and this is the equation for variance. Okay, and in this case I have to take those values only. Okay, in you already see there are total 3 parts. Okay, path 1, path 2 and path 3, and for uh, uh, I get the critical path 33 weeks, which is basically the first one, path 1. That's why I take the those parts, basically 1 to 2, 2 to 3, 3 to 5 and 5 to 8. So 1 to 2, 2 to 3, 3 to 5 and 5 to 8. I have to calculate for those values. I don't need those to calculate those values. Okay, 1 to 6, 2 to 4, 4 to 5, 6 to 7 and 7 to 8. I just need, you can omit these rows here. You can just write 1 to 2, 2 to 3, 3 to 5 and 5 to 8. I just demonstrate this in this way so that you can understand easily, and to for you in your case you have to just use those values. Okay, those rows, this one, this one, this one and this one. So to calculate the standard deviation, what is the value? Basically TP minus TP minus TO, and to calculate the TP minus TO is the equation is TO plus 4 into TM plus TP divided by 6. Again I say TO plus 4 into TM plus TP divided by 6. So this is the equation for calculating uh, TP minus TO. Okay, or you can say time estimate. Okay, or estimate time. So after calculating this, you get 6 here for activity 1 to 2, 12 for activity 2 to 3, 11 for activity 3 to 5 and 4 for activity 5 to 8. Okay, the calculation is done. After that, what I have to do, just divide the value with 6. Okay, to just divide this answer with 6. Okay, I just divide 6 by 6 is equal to 1. 6 by 12 is equal to 2, 6 by 11 is equal to 1, and finally 6 by 4 is equal to 0.666. Okay, this is the answer for standard deviation. And for variance, okay, I have to tell that this is not the actual answer, just I just calculating. Okay, so for variance, this is the equation Tp minus To divided by 6. I already calculated it. Okay, Tp minus To divided by 6 is basically alpha. Okay, is basically alpha. Now I have to square it. Okay, just 1 square 1, 2 square 4, 1 square 1, and 0.666 square 0.444. Okay, this is the answer for all those variance. After that, what I have to do? Just calculating the variance of project time, which is basically sigma square. Okay, calculating the variance of project time, which is basically sigma square. Okay, so what I have to do basically here, just add all those values, 1 plus 4 plus 1 plus 0.01 plus, sorry, 0.444, basically those values, 1 plus 4 plus 1 plus 0.444, and sum of those values is equal to 6.44. And after that, you have to calculate the standard deviation of project time, which is called sigma. So this is sigma square and this is sigma. And how can you calculate this? Simple, just square root it. 6.66144. The square root of this value is equal to 2.54. So 2.54 is the standard deviation of project time. Okay, so the last question, so I already end up the third question here. This is the answer for third question, and this is the starting of the fourth one. Probability that the project will be completed in 35 weeks. So I have to calculate the probability that the project will be completed in 35 weeks or not. Is there any delay or not? Okay, so to calculating this, this is the equation basically. Z is equal to due expected date and date of completion. Due expected date and date of completion, and divided by sigma. Sigma is basically 2.54, and due expected date basically 35, and date of completion is basically 33. What is 35 here basically? Okay, let's check. Uh, okay, I have to check the term due expected. Oh, okay, this is the 35 is basically this one basically. I forget that. So this is the question. Already says you told you that 35 is the total week. Okay, will be completed in 35 weeks. So you have to use this value, due expected date 35. Okay, just subtract it with 33. What is 33? If you don't can't remember what is the value for 33, and that date of completion is basically just show it here with you. Remainder critical path, after calculating all of those parts and finding the maximum time, which is basically 33, which is the path 1. So I just take this value 33 weeks and use this value here, date of completion 33 weeks. Okay, I have to take the maximum date, maximum weeks always. So just subtract it, 35 minus 33, which is equal to 2, and 2 divided by 2.54 is basically 0.7874, and you can also write it like 78.74%. And uh, so there will be a delay. Okay, so there will be a delay. So this is the answer for the second question. I hope you understand everything. If you didn't understand this, just rewatch this video. I hope you understand clearly. So let's jump into another example. This one is blur, so blur, don't worry. This is the activity, and this is the intermediate predecessor, and this is the duration. So the activity starting from A and end here, end to N. Okay, so for activity A, the duration is 3 weeks. For activity B, the duration is 4 weeks. For activity C, the duration is 6 weeks. For activity D, the duration is 3 weeks. For activity E, the duration is 9 weeks. To complete the activity D, you have to calculate the complete. So you have to complete the activity B. To complete the activity E, you have to complete the activity A. And to complete the activity F, you have to complete the activity A. To complete the activity G, you have to complete the activity B. Similarly, others, for example, for to complete the activity L, you have to complete the activity F, G, and H, and the duration or estimated time is 6 weeks. Okay, the question is here basically calculate time estimate for each activity. Okay, calculate time estimate for each activity, or I can say the critical path. This is the critical path analysis. So this is the answer. Okay, this is the answer, and you already see that this is the starting node, because uh, there are total 3 activity A, B, and C. There are no intermediate predecessors. Okay, and that's why I just basically I always have to start from a starting node. So this is the starting node S, and this is the A node, sorry, A activity, B activity, and C activity, and all those activity came from this starting node. And just copy the earliest finish time to earliest starting time of activity B, earliest starting time of activity A, and earliest starting time of activity C. For earliest starting time of activity A, just add those values. 0 plus 3 is equal to 3. So this is the earliest finish time. 0 plus 4 is equal to 4. This is the earliest finish time of activity B. 0 plus 6 is equal to 6. This is the earliest finish time of activity C. Okay. After that, activity D. For activity D, you have to complete the activity B. For activity D, so this one, you have to complete activity B. So this is the earliest finish time, and just copy it here, earliest starting time for activity D, and add those values. 4 plus 3 is equal to 7. This is the earliest finish time of activity D. For activity E, you have to complete activity A. Okay, and this is the earliest this is the duration or time estimate for activity E. So for E, this is the E. So just copy the value E here. This is the earliest starting time. Add those values. 9 plus 3 is equal to 12. This is the earliest finish time. Okay. After that, for F, you have to calculate the earliest. You have to calculate the activity A. We already calculate activity A. Now it's time for activity F. So for activity F, where is activity F? F, this one. So just copy it here. This is the earliest finish time of activity A. Just copy it here. For earliest starting time of activity F, 3 plus 1 is equal to 4. This is the earliest finish time of activity F. After that, for G activity, this is the intermediate predecessor. Basically, to complete activity G, you have to complete the activity B. So to complete activity G, you have to complete activity B. So this is the earliest finish time of activity B. Just copy it here. This is the earliest starting time of activity G. 4 plus 4 is equal to 8. This is the earliest finish time of activity G. Okay. After that, activity H. To complete the activity H, you have to complete the activity C and D. So where is H? H here. To complete the activity H, you have to complete the activity C and D. So C and D. Okay. This is the arrow sign. So the time is 5. Estimated time is 5, and this is the earliest starting time. Okay, in this case you have to since we are in the forward pass session, we have to take the maximum one from those. Okay, 6 or 7, which is the maximum? 7 is the maximum. Okay, that's why I just take 7 here, and 7 plus 5 is equal to 12. 12 is the earliest finish time of activity H. So it's done. For activity I, you have to complete the activity C and D. For activity I, you have to complete the activity C and D. Again, we have to uh, uh, this I activity came from two activity C and D, and that's why I have to count the maximum one in the forward pass session. So 7 or 7, so 6 or 7, which is the maximum? 7 is the maximum. That's why I take 7 here as the earliest starting time of activity I. 7 plus 4 is equal to 11 is the earliest finish time of activity I. For activity J, we have to complete the activity E. For complete the activity J, this one we have to complete the activity E. So 12 is the earliest starting time of activity J. 12 plus 3 is equal to 15. 15 is the earliest finish time of activity J. After that, for activity K, we have to complete the activity FGH. for this one basically. So F, G and H, F, G and H, and this k activity came from 3 activities. That's why in the forward pass session I have to count the maximum one, 4, 8 and 12. Which is the maximum? 12 is the maximum. That's why I take 12 as the earliest starting time of activity k. What is the earliest finish time of activity k? 12 plus 6 is equal to 18. So 18 is the earliest what finish time of for activity k. For activity L, you have to calculate the activity FGH. Similarly, this is the L, FGH, which is the maximum. 12 is the maximum. So take 12 as the earliest starting time for activity L. 12 plus 3 is equal to 15. 15 is the earliest finish time for activity L. Okay. After that, for activity M, you have to calculate the activity I. For activity M, you have to calculate the activity I. Since this activity came from one activity called I, just copy it here. Copy the earliest finish time to earliest starting time of for activity M, and add those values. 11 plus 6 is equal to 17. 17 is the earliest finish time for activity M. Finally, for activity N, you have to complete the activity J and K. For M, N, you have to complete the activity J and K. Since activity N came from two activity J and K, you have to count the maximum one. 18 and 15, which is the maximum? 18 is the maximum. So take 18 as the earliest starting time for activity N. 18 plus 9 is equal to 27. 27 is the earliest finish time for activity N. And we end up here basically. This also the forward pass is stop. Now this is the time for apply the backward pass. For in the starting of backward pass, just copy those values. 727, the earliest finish time will be the latest finish time. Okay, so this is the latest finish time. Subtract those values. 27 minus 9 will be 18. This is the latest starting time. So 18. So just back to this parent node, which is 2, basically k and j. You can either go here and either go here. I just used both of them in this case. 18, it is the latest starting time. Okay, latest starting time is 18. Just copy it here and copy it here. So 18 minus 3 is equal to 15. 18 minus 6 is equal to 12. So I already calculated the latest starting time for activity k and latest starting time for activity j. After that, j is came from activity e. 15 is the latest starting time, so just copy it to the latest finish time for activity e. 15 minus 9 is equal to 6. 6 is the latest starting time for activity e. So and e came from activity a, but you can't calculate it because for activity a you have to take there are two activities, f and e. Okay, you have to calculate e and f both to use or solve this activity. Okay, so get back to the previous part here basically, and k activity came from fgh, and this is the latest starting time for activity k. Just copy it here. Latest finish time for activity g, latest finish time for activity h, and latest finish time for activity f. So now calculate the latest starting time for activity f. 12 minus 1 is equal to 11. Now you can calculate activity a, and in the backward pass you have to take the minimum one. Which is the minimum one? 11 or 16? Sorry, 11 or 6? 6 is the minimum one. So take 6 is the latest finish time for activity a. Subtract this. 6 minus 3 is equal to 3. 3 is the latest starting time for activity a, and this is the starting node. Okay, for starting node all the values are 0. Now this time I have to calculate those actually. 12 minus 4 is equal to 4, sorry 8, which is the latest starting time for activity g, and 12 minus 5 is equal to 7. 7 is the latest starting time for activity h, and h okay, I already calculate. Okay, did I calculate? Okay, no. So for activity m, okay, as like this one, for activity for example activity n, this one also. Okay, the similar case basically for activity n. What I did basically, just copy the latest so earliest finish time and paste it here, latest finish time, and here also here I have to copy the latest finish time So earliest finish time and latest finish time, both of those values are same. Okay, so now 17 minus 6 is equal to 11. 11 is the latest starting time for activity M, and just paste it here because M activity came from activity I. So this is the latest start finish time for activity I. 11 minus 4 is equal to 7. 7 is the latest starting time for activity I. Now you can calculate activity C, because activity C requires two activity H and I. In a backward pass, you have to count the minimum one. So 7 or 7, which is the minimum? Bo- uh, Both of those values are same. You can take any of them. Okay, 7 is the latest finish time for activity C. 7 minus 6 is equal to 1. 1 is the latest starting time for activity C, and end up here. Okay, for now this time you have to calculate for activity L. You already calculate all of those values except this one. For activity L, similarly for activity N and activity M, you have to just copy and paste this value. Earliest finish time will be the earliest, so latest finish time. Okay, so now subtract it. Latest finish time minus activity time. 15 minus 3 is equal to 12. So 12 will be the latest starting time for activity L. So 12 came from, okay, 12 will be used for H, G and F, and I can see already those values have the numbers. Okay, I already calculated it from this K activity, so don't need anything here. So now for activity, uh, okay, let me check. Okay, for D activity I didn't calculated it yet. So for D activity, you have to check for H activity and I activity, because uh, D activity has two child, H activity and I activity, and in this case you have to take the minimum one as the for latest finish time. So 7 and 7, what is the minimum one? 7. So take 7 as the minimum, sorry, latest finish time for activity D. 7 minus 3 is equal to 4. 4 is the latest starting time for activity D, and just use this value because there are only one connection. So 4 will be the latest finish time for activity B. um, sorry, not. So there are two activity basically here, because B activity has two child, G and D. You have to take the minimum one. So for 8 and 4, which is the minimum? 4 is the minimum, so that's why I take 4 here. Okay, so 4 is the minimum. So 4 is the latest finish time for activity B. 4 minus 4 is equal to 0. 0 is the latest finish time for activity B. Now this time you have to calculate the critical path. So for to calculate the critical path, you have to calculate the slack time. And what is slack time basically? Easy basically. It's simple. Just check those values actually. 0 0, not this one actually, from A, B or C. You have to check which one is 0 0 or basically similar. You have to subtract basically latest starting time minus earliest starting time, or latest finish time or minus earliest finish time. You can either this part or either this part. Okay, both of the answer will be same. So for example, this in this case the answer will be 0. So take this path. Okay, B and B, and there are two parts, G and H. So G and D. For D, you can see 4 minus 4 is equal to 0. So you have to take B to D, B to D. Okay, and after that D to H and I. So what I have to take? 7 minus 7 is equal to 0. Again for I, 7 minus 7 is equal to 0. Both of those values are uh, useful. So now what I can take? So since for H, mm, okay, there are a lot of path basically. You can take either this path or you can take either H1. Basically both of those, since both the values are same. So here I just take this one, H activity, because H activity came before I, HI. Okay, that's why I take H activity. And H activity, sorry, you have to take always take the H activity, because H activity comes before I. You have to follow the alphabetical order. Okay, so for H activity there are two childs, one is K and other one is L, and here for K and L, which comes first? K comes first. Okay, so that's why just take it here, because 12 minus 12 is equal to 0. So I have to count this path, h2k, h2k. And why not this? And because this is not in the alphabetical order, because k first, k comes first before L. Okay, after that from K we have one child basically, which is N, and for N 18 minus 18 is equal to 0. So that's why I have to take this path also, K to N. So finally I end up here, uh, b to b to d, d to I, so d to h, h to k, and k to n, h to k and k to n. So this is my final answer. This is the critical path. Okay, now let's discuss about the difference between PERT and CPM. So PERT, the first point is it's full from project evaluation and review technique. Second one is it is event oriented technique. Third one is oh sorry, in the other hand, for CPM full form is critical path method, and in this case it is activity oriented technique, and this is event oriented technique. In part, the part manages unpredictable activities. For CPM it manages predictable activities. For part it focused on time control. For CPM it focus on cost optimization. For part it focus on, sorry, it was developed in 1958, and for CPM it was developed in 1957. For part this one it is a three time estimate, and it is single time estimate. Three times means optimistic time, pessimistic time, and most likely time. Okay, and finally it is a probability model, and this one is a deterministic model. So there's are the difference between part and CPM, and this is also so much important for exam. You have to memorize all those points carefully. Okay, the next slide I just discuss about the advantages of part or CPM. So first one is especially useful when scheduling and controlling large projects. Second one is straightforward concept and not mathematically complex. Third one is graphical networks help highlight relationships among project activities. Fourth one is critical path and slack time analysis help pinpoint activities that need to be closely watched. And this is also important because sometimes the question says you have to write the advantages of part or CPM. Okay, then you have to write those points. And finally the limitations of part or CPM. So there are total basically I think one, two, and three limitations. So first one is project activities have to be clearly defined, independent, and stable in their relationships. Second one is precedence relationships must be specified and networked together. Time estimates and tend to be subjective and are subject to fudging by managers. So these are the limitations of part or CPM. And again this one also important, and you have to memorize this thing. Similarly in the previous slide you have to memorize advantages of part or CPM, and also limitations of part or CPM. Okay, and the fourth one is there is an inherent danger of too much emphasis being placed on the longest or critical path. Okay, finally I think I end up the already finished the lecture. Yeah, I already finished the lecture. So this is the last slide. So thanks for watching. Like the video and subscribe to my YouTube channel. I hope uh, it inspired me so much, because I spent at least 2 hours to draw those draw the first part, actually critical path analysis. Draw this circle, put the values, and this takes so much time. and I can use I can use the slide which the teachers given us, but I didn't use it because it didn't elaborate all of those steps. Okay, that's why I have to write write it from scratch. That's why it takes a lot of time and lot of struggle. I hope you understand everything. If you didn't understand anything, just comment below. I will help you. Okay, and if you need this slide, definitely you have to subscribe this and contact me. Okay, thank you. Allah Hafiz.